What's the most reactive element? Some would say lithium. If we were talking about metals only, that would be true. Some would guess hydrogen because it's at the very top left, and it's a really reactive element. But the most reactive column, the most reactive group, is the halogen group, group 17. And the most reactive gas in that group is the lightest one. So fluorine is the most reactive element on the periodic table. What do the dot diagrams help us understand? Remember Lewis dot diagrams is where we have the symbol in the middle and the dots all around. The dots tell us what the outer electron shell looks like. Does it have 1 or 8? Does it have 7 or 4 in the outer shell? Remember that when an atom is stable, it wants to have 8 electrons in its outer shell, with the exception of hydrogen and helium. They only want 2. Compare anions to cations. Remember my little thing I talked about? I talked about my overweight cat that had bad breath and he wanted to put hair in your lap, and he's got weird looking eyes that look like pluses. Cations are positive. Anions are a negative ion. So a negative ion, anions. Negative ions are anions. Cations are positive. So one of them gives up an electron and it becomes positive. That's a cation. One of them gains an electron and makes it more negative, and that's an anion. I suggest making some diagrams of this to help you understand. What is an oxidation number? This is a number we use to represent the charge of a given ion. Metals tend to be positive, and nonmetals tend to be negative. It kind of splits there in the middle of the table. About what column was that? The column that begins with carbon, we would put oxidation numbers of 4 plus or 4 minus there. So that's the place where it splits. And again, I'll have you some reference information to use during your exam. So polyatomic ions, these are ions that combine and they act like a single atom in a molecule because they are ions. So they have a charge and they go together as a cluster. Some of the examples are ammonium. We talked about carbonate and hydroxide and sulfate and nitrate, those kinds of things. Those are the polyatomic ions. Water molecules are great examples of polar bonds. They have a positive side and a negative side. So if you look at how a water molecule is structured, it looks like Mickey Mouse. The ears are the hydrogens and the little faces, the oxygen. The oxygen has the electrons much more than the hydrogens, so it tends to have a negative charge. The two hydrogens tend to give up that electron more often than they have it, so they tend to be more positive. So we have a positive side and a negative side, and that makes it polar. Know the difference between ionic and covalent bonds. The key words are transfer and share. If it's ionic, it's transferring. It gives away an electron or it gets an electron. And then covalent is where they're sharing electrons. Ionics generally form with polyatomic ions and metals and nonmetals. So you put a metal and a nonmetal together, it's ionic. You put a metal and a polyatomic ion together, it's ionic. Covalent bonds tend to be between nonmetals and nonmetals, and they share electrons. When writing your chemical formula, which element is written first? You're always going to write the one that is most positive first. Always write the cation first. And that means you're probably going to write a metal first in a binary ionic compound. Okay? Identify the name of a chemical formula and vice versa. So if I show you a chemical formula, you should be able to name it. This is from chapter 18. Go back and look at the notes that we did. We kind of built some little diagrams so you could do that or review what it says in chapter 18. And then you should be able to go from a chemical formula to, or a chemical name to a chemical formula. So if I say something like magnesium oxide, you should be able to break that down to how many magnesiums and how many oxides you would need to have a stable formula. And then we've already talked about this next idea, that hydrogen and helium want to have 2 electrons in their outer shell, but everything else wants to have at least 8. Well, exactly 8. If it has less than 8, it's looking for some more to pick up. You need to compare superscripts, subscripts, and coefficients. Superscript is what we put in a chemical formula or along with an element to describe its charge, so we're describing an ion. Subscripts tell us how many of that element are in a given chemical formula, and the coefficient tells us how many of each molecule we have in a balanced equation. You should probably make a diagram of this to help you understand the differences and when they're used. Identify the 5 types of reactions. Describe what happens in each. Make a diagram. 5 types of reactions are synthesis, decomposition, single replacement, double replacement, and combustion. Remember our discussions about the happy couple and all of their adventures, and that will help you get those ideas down. Why is the law of conservation of mass important to chemistry? You can't balance an equation if you don't understand the law of conservation of mass. The mass you start with has to be equal to the mass you end with. So when you're balancing an equation, you have to have exactly the same number of elements on both the reactant side and the product side. What do these symbols mean? If we are looking at a chemical equation and it has an L in parentheses, that means it is a liquid. If it has a G, it is a gas. If it has an S, it is a solid. And if it's a Q, that means aqueous. And that's a fancy way of saying it is dissolved in water. And you also need to know how to balance chemical equations. There will be a couple of these on the exam, but not a big chunk of them. So you need to just think about finding the equal number of elements on both sides. I've shown you split, list, add, and multiply as a strategy for balancing these. So use what I have given you as tools. All right, this is a really long video, so I probably need to break this up. I hope you've had a nice time listening to all of this, and good luck on your exam.